Hello everyone. In the previous video, we have already seen the internal working of a microcontroller, including memory and architecture, instruction cycle, timers, counters, etc. In this video, we are going to focus on peripherals, how a microcontroller is going to interact with the real world and environment. So basically, we will divide this topic into three parts: input, processing and output. So a microcontroller cannot directly control or sense the real world signals. Hence peripherals वो मॉड्यूल होते हैं बेसिकली जो माइक्रोकंट्रोलर को हेल्प करते हैं टू इंटरैक्ट विद द रियल वर्ल्ड. So microcontroller peripherals are the hardware module which helps the microcontroller to read input through sensors, then process data through microcontroller and generate the output through actuators. So peripherals are an important part which will help in robotics, automation systems or embedded systems, etc. Let us start with the GPIO, which stands for General Purpose Input Output. So basically, when configured as the input, the GPIO pin are going to read the signals from the environment. जैसे कि जब हम किसी GPIO पिन को किसी पुश बटन या सेंसर के साथ कनेक्ट कर रहे हैं तो it is gonna read the signals from the external environment like sensors and push buttons, etc. There is also an important concept here which is pull up and pull down resistors. So when connected without a pull up or pull down resistor with the GPIO pin, it can enter in a floating state which can cause unstable reading. जब हम किसी पुश बटन को GPIO पिन के साथ कनेक्ट कर रहे हैं without any proper reference given to it, it can give the undefined voltage which can cause the pin to enter in high state or low state without any reason. What are pull up and pull down resistors? So pull up resistor. This is the pull up resistor. And this is the pull down resistor. So pull down resistor is gonna act exactly opposite of the pull up resistor. पुल अप रेजिस्टर GPIO को डिफॉल्ट हाई स्टेट में रखता है. Whenever the button is not pressed, the pin is going to stay in the high state. When the button is pressed, the pin is going to connect with the ground and it will go into the low state. Exactly opposite काम करता है pull down resistor. The pull down resistor is already in a default low state, but when the pin is connected, it will go in the high state. So basically pull up and pull down resistor ensure करेगा कि पिन कभी भी floating state में ना रहे. Either it is connected to a high voltage or a low voltage. Many real world signal like temperature or light are analog in values. So we cannot directly process the analog values to the through the microcontroller. So we have to convert it from analog to digital through ADC, which is analog to digital converter. So the analog to digital converter will consist of blocks like the ADC block will have a physical signal like temperature, light or pressure. Then the physical signal will be given to a sensor. The sensor will convert giving it to the microcontroller. The signal conditioning block will amplify the signal. For example, if we need a value between 0 to 5 volt, but the value given from here for the physical signal will be converted into an electrical signal. For example, the temperature is converted into a voltage, and in the output we need a voltage between 0 to 5 volt, but here it is giving between 0 to 2 volt. The signal conditioning block will amplify the signal. It will keep the signal stable and noise free. Then the signal conditioning block will convert it into a within specified voltage range, as I have already told. Then it will be given to an ADC converter. The ADC converter will convert the analog value into a digital value. For example, if we are using a 10-bit ADC and we want 5 volt, the value will be, for example, 512 in digital. The digital value will be given to the CPU for processing. The CPU will process the data, it will control the signals, it will make decisions and display the data. So the overall part of the ADC is the physical values will be given to the sensors and collected and then given to the signal conditioning block. Then will convert it into the digital values and will process the data through CPU, and then the CPU will make decision and control the output. Now that we have already understood the input stage, we will move towards the processing stage, which consists of timers. Timers are time-based module which is used to generate the delays or PWM generation by using the internal clock frequency, internal clock pulses. Every microcontroller has an internal clock pulse. Generate pulse at a fixed frequency. So, a timer consists of clock, every microcontroller has an internal clock pulse. So the internal clock pulse is internal clock pulse at a fixed frequency. The clock pulses are given to the prescaler. Why a prescaler is required? Because the clock frequency is at a very high speed. So the prescaler will divide it with the clock frequency. For example, if the pulse frequency is 16 megahertz and the clock frequency is 16, so it will divide 16 megahertz by 16, and the prescaler will give a value like 1 megahertz for generating the delay. So it will basically reduce the clock pulses for delay generation. Then it will be given to a counter. For example, a counter is basically used to count the clock pulses. If a counter is 8-bit, it will count from 0 to 255. Then the counter will give the values to the overflow. The counter will count the clock pulses from 0 to 255. Then it will be given to the overflow. If the overflow flag is high, then it will again start with 0, and thus it will generate an interrupt or trigger an event. So timers are for generating PWM generations or delays. Time for the output devices. We can also configure GPIO pins as output. By using GPIO pins in the output mode, we can control the external devices like relays, actuators, and motors. We can also turn the device by using GPIO as an output. We can also turn the devices on or off. But in many real-world applications, we don't just need to turn the devices on or off. We need to control. We need a variable control over the devices. So we can use a PWM. PWM stands for pulse width modulation. PWM is used to simulate the analog output using the digital signals. We can also control the power delivered by the device by changing the duty cycle. It can be used in various applications like controlling the speed of the motors by adjusting the brightness of the LED